Welcome to the Dev Banner. This is Eric. This is episode 8 with the on-hand tutorial, and we're going to change things up with the program. And this episode is all about that and those changes. And I think it's exciting. This is one of the things that I eventually wanted to get to. Actually, I wanted to start with this pattern that I use all the time in my development, but I thought I would save that until now, get the program out there, get it working. So hopefully you've gone back to episode 7 and to go into the done, episode 7 done, get repository and get the latest. What that will give you is some minor changes I've made, and I actually made some other changes, very, very minor, but overall we're going to focus on changing our storage. Up to this date, last 7 videos, we've been doing using just a file. Not very efficient, and it won't scale very well as you get more and more data. So we're looking at SQL, and I'm not going to go over how to install SQL or which version you want to use. I'm going to be using Postgres. It's free. I use a Mac, and I use a tool called Homebrew. I install it, and it will install the latest for me, and it will actually start a server up. And it's kind of nice. So I've done that. I actually have MySQL, and I actually use SQLite 3 on some occasions, depending on what the application needs. But today we're going to use Postgres. So we're going to start with that. But in order to do that, all of our files or all of our function calls have been really going and just hitting the file, and it's a direct correlation, a direct call from let's say one of the managers, for instance. If you come over here, we'll go in internal, and if you come look at the entities, for instance, let's look at category, for instance. This manager holds all of our calls and business logic or whatever, right? And if you notice that we call that data like data create directly, and in the industry that is called tightly coupled, and sometimes we don't want to have that. So an engineering methodology is to loosely coupled. And in Go, we do that through interfaces. If you've gone and watched my interface video, go look it up on How To series. I talk about interfaces, and I talk about this pattern called dependency injection. And I just love it. I use it all the time when my code has to talk to or interface with a like a third party. And in this case, it's a database. It's a storage level. So I'm going to bring this up. This is the same wireframe or flow, or however you want to say it, of kind of how I do things, especially when it comes to these kind of applications. And in this case, we have this UI layer, or in our case, we have a terminal, just a CLI kind of application. And we pass down the struct into what I call my logic layer, or my business logic layer. And this represents that manager.go. And then what we'll do is this manager.go will own a interface that our storage layer we can use. And the dependency is injection in this case is owned by the business logic. And then you can inject through the interface, which storage you want to use. Hopefully my code will make sense. And in that case, you can say, I want to use a database, a SQL engine. I want to use a file. I want to use something like, you can use MongoDB. You can use a NoSQL, Redis, any kind of key value store if you really wanted to. In this case, for the data that we're using, it's more transactional data. So a database or a file is better, or you can mock it so that you can test. And so in this case, we're going to create an interface. We're going to make sure that through some logic, we can either choose a DB or maybe even a file and stick with the file. And then it becomes loosely coupled between these layers. It becomes loosely coupled, and then in the future, or if you ever need to change anything, or let's say a new Spandangle awesome storage comes out, you just need to fulfill the interface, write your logic for your storage, and then start using it, and you don't change anything in here. You don't change any of your business logic. Same goes with the UI. You want to use a web, you want to use gRPC, you want to use, a legacy UI, not legacy, a native UI. You can use that and still call this logic, and that go, the data flows down from layer to layer, and you don't really change. You don't need to change everything because everything is loosely coupled. So with that, we're going to go through, and I'm going to use this view again. So one of the things that I've changed is I added a environment variable called prognos use SQL. I'm going to set defaults by default, and I added this little helper function to because you need to, at least on Mac and on Linux, the environment variables have to be a text, and then we convert it to a Boolean. I could have used just true and false as strings and did this comparison, but just something that you can do. And then I added a host, a DB, a user, and a password. Now that in and of itself is pretty, we've been through this. This is pretty simple, pretty generic. And so I provide those environment variables through my environment. Mac, I'm using Bash, so it would be my Bash profile. And I set those. You can set them at runtime, at compile time and runtime if you want. But that's something that I added. And then I added a new file, a new folder, a new file under internal called storage. And this is my connector for Postgres. It uses those config, and I handle both. Do I have a password or not? Sometimes when you set it up locally, you don't set it up with a password. You use root or the name of the user that is running your system, and it creates Postgres creates that for you with no password. And so I handle that. And I'm using a pattern, a singleton pattern, that basically says, hey, I have this local or a global variable called PSQLDB. I'm using a library called SQLX. I really like it. I've been using it ever since I got introduced to it, just because it makes things a lot easier. I will show you what those are, and here later in the video. So I have a global, and using that. I have a global this, also this Postgres connection. I don't necessarily really need that. Um, but if it hasn't been instantiated yet and it's still nil, then it will go ahead and try to connect. And then all the SQL packages have a connection pool built in. But in this case, you just need one connection, which helps the database because it only has one connection. And then it uses the internal connection pool if you have multiple calls. And those pools can be changed. I'm not too sure which this PQ library, how many it sets as the default pool. I think it's like maybe like 20 or 50. Don't quote me on that, but I never have that many queries going at one time. But anyways, it's handled all through that. And so this is to connect and being used. So if you'll remember this Postgres init, we use that a little later. And so some of the major things that I've changed, and for this episode 8 to do, I only changed the account entity. And one of the things I've changed, I added, was a SQL. Just like file, I've changed to SQL. And what I've done is I've created this function called init SQL. And here's where that Postgres init gets called, and it creates this database. And it gets added to this guy's struct. Now this is all new, and this is part of the injection. So this struct would be the same thing as this guy right here. And in order to handle that, we're going to go back up to the manager, and I'm going to create an interface. Now, once again, if you're not familiar with interfaces, go watch my video on interfaces and why they're great. But it's that contract, meaning that if a struct has methods that have all these, then you can use this interface. If it's being used as like a variable, you can use that struct in place of this interface, as long as you have these methods. So if we come back over to, so I have a read, list, create, update, delete. Those are the things that you should be familiar with. So if I come over here, I have a read, list, and so on. Once again, this creates a method on that struct, this account SQL data, and that fulfills this interface. Now I have a new struct at this level. Now before we didn't have this, we just kind of called read in the package of account. So we're going to do things a little differently. We're going to instantiate this struct, and we're going to inject this account data adapter, this interface. And this guy owns a variable that is of type account data adapter. And when you create it, this little helper function, you pass in the account data adapter and you assign it, and then you send back an instantiated account manager. And then when you call that, you call it read, and it will then call whatever adapter you've sent in when you initiated this manager, and you're going to call the read. So in this case, if I sent in SQL as my interface, as my struct, then it will call this read versus this read. And one of the things I've changed, you'll see that I added account filled data struct. And so I changed all these codes. You'll see that I've changed just the this method signature to be able to be influenced or be able to be interface, the injection interface. Okay, so you'll see that that's similar. And then in order to handle SQL, I added some struct tags. If you're not familiar with struct tags, I have a video about structs. And all that is just some metadata. In this case, it's metadata for this field on this struct, but the DB going in and out of the DB, it uses these fields. So I have a database in Postgres that has that's called account, and it has an ID account name. So if we come over here to the SQL, I like to set up my SQL like this, just because it shows me how that SQL is looking. I actually can take this out, put it in a SQL client, run it, make sure it works okay. Postgres uses the $1, where like MySQL uses the question mark as a placeholder. It's not necessarily kind of like interpolation. It's not like interpolation. It's handled a little differently. But this was where SQL X comes in, and you'll see that I'm including it right here. They have some helper functions called get. That gets you a 1, and it uses this account. You got to pass in a pointer to this interface. So if I come over here, you'll see the destination is an interface. So it could be anything, but what it does is behind the scenes, it uses that struct tag to know how the data to push into each field in that struct. Get is a single, select is an array. So in this case, I have an array of accounts. You have a named exec, as long as you have this colon in front of that struct tag name. And it's important that you follow the same case and underscores or whatever. This will handle for you this named exec. It does have a regular exec, which I'm doing right here, but SQLX is a really great package. I really love it. I use it all the time. So the injection now comes down to how do you do it. So let's go look at, so that's account. So let's go down to the records, the terminal. So I'm at my level, I'm at my UI level, and I'm going to own a account manager, and I'm going to use this function init. This is kind of a guarantee through the Google team to say that once this file gets used on this package, then, or for accounts, it will run this function once. So I'm going to init this storage, and you saw that before in account, and all that's doing is it's going to init the SQL, and in this case, come back over to account and model. This init storage, this is where all the magic happens. If my usequel from my environment variable is set to true, then I'm going to do this init SQL. If not, I'm going to give back the file data. So if you forget to do it, you're at least going to get something. Now you can make this as a mock, and the mock won't do anything, but at least compile, and it will at least give you something to work with as a dependency injection, because that's where really what this is happening. I'm determining through this function which dependency interface I'm going to inject into this manager. and it's done like that. And what AS is that adapter, that interface of either SQL or file comes back, and I create this new account manager. And then I use this account manager down the line. I use it right here where I do create, on the create, read. Now, one of the things that I changed from last time, I was having problems with Postgres. The new line was getting an extra character, and plus I wanted to show new line because this would have shown nothing. Actually, it would have made a new line. So I actually just say the word new line on the display. But coming back to here's the update and so on. And I do that in a few places. Now, for instance, that's for the count, but in count column, I am doing something, I need to get accounts. And so I still do the initial storage, and this is another pattern that I use quite frequently, where if I just need to do a one-off, I need to get the type. I have a really quick way to init the storage, and what that will do is determine whether it's SQL or file, send back the adapter, and then create the new adapter, and then just use it really quickly, and then I'm done. The reason I could have done just this and called as.list, but I like, if I'm going to create something, a struct, because that's the main mechanism of how you're moving data up and down, creating, that's how you move data up and down these layers, right? Then I want to make sure that the business logic gets called, and so that's why I call the manager also. But I could do AS right there, and that would be perfectly fine. So I do that a couple places. I also do that right here on the read. And so in that case, and I do that actually quite a different places. More of the changes is just that trimming, getting rid of the space. That's getting rid of any space really. I could do that trim suffix and postfix, but I couldn't use trim space because trim space also took out the new line if it was a new line. So those are the changes that I made, and let's go ahead and run this. And I'm in command terminal, and let's go ahead and run this. Now to prove that, I'm going to come in and we're going to look at, I added another one right here for the file. So let's go ahead and do a list of accounts, and you'll see that I have two, and they're not the same IDs. And this new owner line, this new one, the account name new is not in here. That's actually coming from a database. And to show you that, let me get the right one, because I have a whole bunch of these open. Actually, I was on the right one. So this is my little testing of that, why the line separator has a space on it. It's kind of weird. I haven't figured out why, but here's those two that I've shown you. Like I said, it shows a line separator. It shows it as a paragraph indicator, but it actually has a space behind it. And I don't know why Postgres is adding that, but that's not a problem. I kind of fixed it with code, and that's okay. So that is the change. And so what I'm going to be doing for the next video is going to go ahead and change all these entities to have to use this pattern, this dependency injection pattern. And then from there, you'll be able to use any storage, and we'll be able to mock and test manager if we wanted to. Maybe that will be the next video. I've got a video that I want to do about that using a tool that the Go team has put out called MockGen, and so maybe that might be the next video. If not, just look for that how-to video, and that is I love interfaces. I use them quite frequently, and when I was first introduced to them, I thought, oh great, here's some more, C++ abstract kind of things, but the way they do it makes a whole lot of sense, and it's really, really easy for you to start off thinking, if I'm going to call a third party, but I want to test the code before I call a third party, how do I do that in an environment where I'm just testing, and I don't want to make an email. I don't want to send out emails. I just want to mock something and say, okay, use this mock and send out, fake emails, or just print them out to standard out where I'm saying, yeah, I'm emailing these, but the logic beforehand or logic afterwards is not affected by your decision to send the emails or not, or call a database or not, or call a third party or not. That's where interfaces, and that's where this dependency injection pattern comes into play. Really, really enjoy it. I hope you learned something. Thanks for joining. See you next time. Please subscribe to the channel and make sure notifications are turned on.